Welcome to the Study Hacks Institute of GIS and Remote Sensing. So, first of all, I will give you an announcement for our upcoming online training program. So, basically, this class will be start from 10th March. Okay, and admission last date is the 8th March. But first 10 registered people will get the 50% discount. So now this 50% discount is enabled. You can easily get the 50% discount. This is the total 7 days online training program. Class will take for the Friday and Saturday in a week, and class duration is the each day for 3 hours. And this is the time about that. And if you want to join this online training program, you can simply contact in this WhatsApp number, or you can also contact with this email. So basically, in this online training program, you will learn all of those things from beginners to advanced level on Google Earth Engine for remote sensing analysis. So I already add all of those things in the video description. You can simply check it. Then you can easily join. You can also get some benefit. You can get the course certificate. You can get all of those materials, mainly slide PDF. You can get all of those practice code. You can get all of those recorded class. You can also get the lifetime teaching support. It's very important as a beginners. When you want to learn the Google Earth Engine platform, you face a lot of problems. So that's why when you join this online training program for one time, you can get the lifetime teaching support. So as soon as possible to get the 50% discount, simply contact in this WhatsApp number. Also contact with this email. Okay, thank you. Okay, so hello everyone, welcome. Can you hear me? Can you hear me?
Yes, sir.
Okay, okay. Just we are waiting 1 minute for joining all of those other participants. Then we'll start.
FM, sir.
Yeah, please.
Listen.
Yeah, it's recorded. You can easily get this recorded class from our Google Classroom. Okay.
Okay.
I already put the link. You can easily go to this link. You can easily get this classes. All of those recorded class you can easily get from here.
Actually, I did not base. I did not have a basic knowledge of Python or some JavaScript, sir. I newly joined. That's why I can.
Yes. Okay. So
Sir,
So basically, in this online training program, you will learn all of those things from beginners to advanced level. We try to complete it. And first day session, you can check all of those recorded class. I think you can easily understand all of those things for the Python, JavaScript, how we can easily work with the Google Earth Engine with the Python and JavaScript, and you can easily work with that. No problem. Okay.
okay, sir.
So
That's
it's
why I'm asking. I don't have basic knowledge of Python, JavaScript, any other coding software, sir. That's why I asking.
okay. Okay. No problem. You can easily get all of those things from here, and you
Okay.
can practice. Okay.
Okay. Thank you, sir.
Okay, so now we'll start today's session. Just I simply share my screen. Okay, can you see my screen now?
sir. Yes,
Okay.
sir.
Okay. So
Slowly.
okay, so basically today is our second day. Okay, first day we try to discuss this type of topic. So mainly for the today's session, I will okay. Let me check about the started the recording. Okay, so basically today is the second day, and mainly today I will try to discuss about that filtering and displaying the satellite images. Mainly Landsat, Sentinel, MODIS, how can it be filtering and displaying these satellite images. We also try to discuss about that. And then we talk about that satellite composite, how we can easily create the different types of composite and how we can easily create the band combination as well as how to export satellite imagery, mainly Landsat or Sentinel or MODIS from Google Earth Engine platform. Then how we can easily import, filter, reduce, clip, and display the raster data in Google Earth Engine platform. As well as also try to discuss about that time series chart from ready-made dataset and also talk about the export any shape file. So today I also try to discuss about this all of this topic one by one. So I hope you can easily get this idea about that. So let me open my slide. So let's So first of all, here you can see the Art Engine public data catalog. Okay, so basically, we already know about the Art Engine. This in this public data catalog, we can easily access all of those satellite images, such as Landsat, Sentinel, MODIS, different types of train dataset, land cover dataset, atmospheric dataset. This type of data set we can easily access from the Art Engine public data catalog, and this type of data is all time it's updating. Okay, it's the daily updating all of those data, and this is the link about this data set. You can simply go to this link, then you can easily get all of those data set, mainly Art Engine public data catalog, all of those data set. So in this time I simply go to this link and try to open this data catalog. So just I simply open this code editor. Okay, so in this time you can see it. You can simply select your email, which email you want to use to open your Google Earth Engine account. So in this time I use this first email. So just I simply continue with this email. So now it's open my code editor, Google Earth Engine, JavaScript API code editor open. So here you can see this is the code editor, and now I want to simply click on here, and you can see the browse data catalog. Okay, just simply click on the browse data catalog. So now this link will be open and we can get all of those data set. Mainly you can see the Landsat, Sentinel, MODIS, all of those data set I can easily get from here. So further this type of data I can easily use and then create the different types of analysis. So in this time, suppose I want to work for that MODIS. I simply click on the MODIS, and here I can get all of those MODIS datasets, such as MODIS adjusted reflectance daily dataset, MODIS albedo daily dataset, MODIS BRDF albedo quality dataset, Terra surface reflectance dataset, okay, Terra snow cover daily dataset. So there's a lot of dataset. Like you can see the land surface temperature dataset for the MODIS, Terra surface reflectance, thermal anomalies, fire daily global dataset. Also you can see BR daily dataset, land surface BRF daily dataset. So there's a lot of data set we can easily access from here for the MODIS. So in this time, suppose any data set I want to work, then how I can perform this work. So here you can see, suppose I want to work with this data set. Suppose this data set I want to work. Mainly it's the vegetation indices data set, 16-day global 250 meter resolution. Okay, so basically it's the resolution 250 meter, this dataset 500 meter resolution, this dataset 1 kilometer resolution mainly pixel area. Okay, this dataset the 500 meter resolution. So in this time I have to work with the dataset. Basically this dataset called Terra vegetation indices 16-day global 250 meter resolution, and I simply click on here, then I can get all of those things about this dataset, such as dataset availability time. You can see we can get the dataset from year of 2018 February, from 2024 17 January. This is the time about this dataset, and this dataset is the updating daily. Okay, it's the updating daily, and this is the dataset provider. Mainly this is the dataset provider, and you can see Art Engine snippet. Okay, every dataset we can get the Art Engine snippet. This type of snippet, it's the unique ID of this dataset. this is the unique ID of this data set. So every data set have a unique ID. Okay, suppose this is the data set for craft vegetation indices. This data set unique ID. This is the unique ID about this data set. It's called the ArcGIS snippet. And we can get all of the description about this data set, mainly how it will be work, and mainly when you use this data set, we did not get any kind of cloud, heavy aerosol, cloud shadow. This type of pixel in this time, it already masked. You can see it also show the description. It's masked for water, cloud, heavy aerosol, or cloud shadow already removed from this data set. So that's why when you use this data set, we can get the very clearly vegetation map, mainly clearly NDVI map or EVI map. We can easily get it very clearly because this type of water, cloud, heavy aerosol, cloud shadow is already removed. And this data set have a two product. You can see the mode is NDVI and EVI. Product are computed from atmospherically corrected biodirectional surface reflectance that have been masked for water, cloud, heavy aerosol, and cloud shadow. So basically this data set contains the two band. One is that NDVI, another is the EVI. Okay, so NDVI mainly normalized defines vegetation index, and EVI mainly enhanced vegetation index. Okay, so in this time, suppose I want to use this data set, and this data set is the global data set. Okay, globally we can easily monitor the vegetation using this data set. So in this time, I want to use this data set and then make the vegetation map. How I can do that? So this my data set and this my code editor. So first of all, I need to import this data set in my code editor. Okay, so how I can import? For importing this data set, you just simply copy this snippet from here, simply copy and then paste in your code editor. Okay, it's simply paste and then give a variable name. Suppose I put the variable name is a data set. Okay, so in this time, what happened? This is my image collection. This image collection I stored in a variable. This variable name as a data set. You can put any name. Variable can be any name. Okay. So now this is my image collection. This image collection I stored in a variable. This variable name is the data set. So now in this time, this image collection have a two band. We can see this image collection have a two band. One is the NDVI and another is the EVI. I want to work for NDVI. So how I can do that? I just simply use a function select and then put NDVI. Just it. So in this time I put the select function and put the NDVI because this image collection have a two band. I want to work for a specific band. I want to work for NDVI band. So just I put here the NDVI. So now I want to check how many images are available for NDVI between this time period, year of 2000 to 2024, for the whole world. How many images are available? So for that, you just simply write the code print. You just simply copy the variable name data set and paste here, and then use the function size function. So mainly this size function determine how many numbers, how many images make this collection. So click to the run. In this time you can see it computing how many images. We can get the total 551 images for the whole world between this time period, year of 2000 to 2024. In this time, suppose I want to filter this time period. I need only for the specific time period. It can be summer season, it can be rainy season, or it can be any specific year. So how I can do that? For filtering this time period, we simply use here the filter date function. Okay, just put here a filter date function. And now in this time, I put here the start date and end date. Okay, suppose I put this time period year of 2023, 1st January. Suppose from last date I simply put year of 2023, December 31. Okay, so I take the 1 year data set, year of 2023. So now further click to the run. In this time you can see for the 1 year how many images I can get. I can get 23 images for the 1 year. In this time I want to check what's the time interval for the 1 year. So in this time you just simply print, suppose print this data set Then we get the interval time. Suppose first image to second image, how much time? You can see, click on here and go to the feature. Here you can see the it's the 16 day. Okay, first image you can see 1st January, then 17 January. So interval is that 16 day. We can get the 16 day, all images 16 day interval. So that's why this dataset called the 16-day global. Okay, it provides the 16 days average result. So that's why it's called the 16-day global dataset. Because here you can see we can get the interval is that 16 day. Each images 16-day interval we can get in here. So in this time, this dataset I want to visualize in my map. So how I can do that? Very easy. In this time, I need to reduce this image collection. Here I can get for 1 year 23 images. This is my image collection. This image collection I want to reduce. So in this time we talk about the reduce. It's very important for the reduce. Mainly reduce is a statistical function. It's a statistical function. So mainly it reduce using suppose average, then median or standard deviation or mean, minimum or maximum. Okay, so basically we are use the reduce this type of calculation, suppose average, median, standard deviation, minimum, maximum. Okay, in this time I want to use this total 23 image collection and reduce my image, and I want to create the average NDVI map between the year of 2023. So for that, what can I do? Just I take a variable. Suppose I put the variable name is that average NDVI. You can put any name, no problem. Then call your collection. So this my collection data set and paste here. Then I simply use a function reduce. Okay. Then I need to define how I can reduce. In this time, I want to reduce using the average function, average, mainly mean. So user ee dot reducer dot okay. So in this time, this is my data set. It stored total 23 images. Okay. So this data set I want to reduce. How I can reduce? I want to reduce ee dot reducer dot mean function. In this time, what happened? In this time, this variable stored the average result. This average result come from total 23 images. Okay. So now further, I just simply add this layer. Suppose map dot add layer and call the average NDVI. Simply copy and paste. And further, click to the run. In this time, you can see it loaded the layer for the whole world NDVI map. Loaded year of 2023. So now it shows this type of gray color, but we can easily add the color, suppose proper color for vegetation. So for that, I just simply copy their demo code. Here you can see they're already provided demo code for the color. I simply copy and then paste. In this step, they mainly make a dictionary using the curly bracket. They put the dictionary and put at the mean value start from the 0 max up to 8,000. And then use the different types of color code, hexacolor code. I simply copy this variable and then paste after the object name, because when for the first class I tried to discuss about that. In the map.add layer, I simply open this function in here. Suppose map.add layer. Here you can see first argument is the object. Okay. Second argument is the visualization parameter. Then third name, then shown and opacity. So here I put my object. My object, this is my object, average NDVI, it's my object. And this is my color code, mainly visualization. It is stored in a variable. This variable name is the NDVI viz. So I put the NDVI viz. Okay. And then I put here, suppose layer name. I put the layer name. In this time, show the layer 1. I put the layer name, suppose world NDVI map, suppose 2023. So now click to the run. In this time, what happened? You can see it added the layer name world NDVI map 2023 and also loaded the NDVI map for 2023 for the whole world NDVI map. We can easily generate. using this image collection. So now we can easily get about that where the low no vegetation or high vegetation we can easily get from here. So it's work for the whole world. But in this time, I don't need for the whole world. I need for a specific boundary. So how I can do that? Previous class I tried to discuss about that how we can easily upload our boundary shape file. Suppose I already upload the boundary shape file. Suppose okay, so just I simply import. Click on here. Suppose I need this NDVI map for this boundary. Suppose it's a Bangladesh sub-district shape file. So I want to need this result for this shape file. Okay, suppose this shape file I want to use and then I want to need this result. So how I can do that? Simply import. Okay, then in this time you can see it imported and default variable name is the table. I just simply change it. I put the name as the ROI. Okay, and then further I just simply put here clip function. Here clip with ROI. Okay, so now click to the run. In this time this data set is loaded only for my boundary of Bangladesh. You can see the NDVI map for year of 2023 for Bangladesh. So you can easily upload your boundary shape file and you can easily clip. Mainly we have to use the clip function with our study area, which is ROI. Suppose I just simply show you the another data set, previous class, mainly US DOS data set, and I simply import this data set. Basically, this data set imported all of those international boundary polygon. So in this time, I want to use this data set and try to filter my specific country. Okay, so for that, I just take a variable. Suppose I put the variable name is a suppose country, and then I call this data set table. This table I need to filter. How I can filter? Art engine dot filter dot equal. What's equal what? I simply put here that country name and put the country name, suppose Bangladesh. Okay. So in this time, what happened? In this time, this Bangladesh country boundary shape file is stored in the country variable. I simply copy the variable and then clip with this variable. Just paste here country. So now click to the run. In this time, you can see it loaded the shape file for country boundary of Bangladesh. We can get the result for Bangladesh. Suppose I put here the another country. Suppose I need the result for Pakistan. Just use the Pakistan and then click to the run. So now it loaded the layer for Pakistan, but it not focus. I need to center view of Pakistan. So for that, we are use the same function, map.center object. Previous class I did discuss about that center object. In this time, I want to object on this Pakistan country boundary shape file. It is stored in the country. Simply copy the country and paste here, and then suppose zoom level 10. Click to the run. So now it directly focus on the country boundary of Pakistan and then visualize the NDVI map for year of 2023. Suppose I simply put here that suppose Saudi Arabia. Click to the run. In this time, we can get the result for Saudi Arabia NDVI map year of 2023 for the whole country boundary. Okay. So this type of things, it's the vegetation or cropland. We can easily detect from here. Okay. As well as any country boundary, simply put in here. Just put the name. Suppose I put the name Germany. Click to the run. So now it visualize about that Germany NDVI map year of 2023. Or you can put here that suppose click to the run. So now we can get this NDVI map for the Zambia. So any country boundary, you can simply put this name, then we can easily get this result. Further, we can easily download this type of map from here and use it for our research paper, or make the map using ArcMap software. So I'll show you the later how we can easily do that. Suppose you put here that click run. So now we can get this result for Colombia. Okay, so in this time it shows about that NDVI map year of 2023. So in this time, this map has a problem. This problem is that we already know about the NDVI range. Suppose I search here NDVI range. NDVI range mainly always negative, positive 1 to negative 1. Okay, this is the range about the NDVI. But in this time, you can see in my map, it shows this type of result. So click on here. I can get NDVI value, you can see 5,628. Click on here, then I can get the NDVI value 2,428. So in this time, this value is not reprojected. Okay, so in this time, I need to reproject this scale value. Then I can get the proper range about the NDVI, negative 1 to positive 1. This type of range I can easily get from here. In this time, it show this type of value. Okay, it's not reprojected this scale value. So in this time, how I can reproject this scale value and get the proper NDVI map, which range belongs to negative 1 to positive 1, this range. So for that, in this time, you can see here, this data set already have a scale value. You can see it's already have a scale value 0.001. So in this time, I just need to use this scale value and then reprojected this NDVI value. Okay, so now how I can reproject? For the reproject, so I just simply write the code in here for the reproject. Suppose reproject the scale value. Okay, so for the reprojected the scale value, in this time, all of those images, this is my image collection. Okay, here total 23 images. All of those images I need to multiply. All of those images I need to multiply with this scale factor, mainly 0.001. Okay, so in this time, this step is that I will write the step. Suppose a step image collection, just multiply with a scale value. Okay, so not only for this data set, for the modis we can get this type of scale value. Suppose I show you the another example for another data set. You can see, suppose this is the another data set. Suppose evapotranspiration. This is the another data set for evapotranspiration. Here you can see it also have some scale 0.01, also again 0.1, 10,000. So in this time, when you want to work for this, suppose total evapotranspiration, then you have to multiply with this scale 0.1. Okay, so basically in the modis product, we have to reprojected this scale value all time. Not only for that, even to check the another data set. Suppose for us, you can see this is the data set. This is the LST data set, mainly day land surface temperature data set. You can see it also have a scale. Okay, 0.02. So all time when you want to use this type of data, you must be reprojected this scale value. So how I can reproject? Simply image collection multiply with scale value. Okay, suppose in this time we can get the image collection total 23 images. Okay, these 23 images I need to multiply with a scale factor, mainly in this time 0.001 for NDVI. You can see for NDVI. Open. Okay, so you can see here for this yeah, so this is the, for this NDVI we need to multiply with this factor. This is a factor, a scale factor 0.001. So now how I can multiply? all of those images at the same time. So in this time, I can get the total 23 images. Also, you can see we can get that this type of feature. In this time, you can get the total 23 images in here. So in this time, when I do one by one, then it takes a lot of time. Suppose I take the first image and multiply. Then I take the second image, then multiply. Then I put the third image and multiply. Then it takes a lot of time. For that, in this time, we have to use the concept of function. So mainly function, previous class I tried to discuss about the function, mainly how we can easily create the calculator and multiply or addition, subtraction, this type of things we try to discuss. In this time, we have to use the same concept and then reprojected this scale value. Okay, so first of all, I create a function. Just give a variable name. You can put any name as a variable. I put the name, suppose scale ndvi. Okay, and then equal sign and put here the function keyword. After that, put the element name. In this time, element basically element how many images you want to work in this time. In this time, you can see here total 23 images. If you want to write, suppose image, then put here the image 1, then put here the image, suppose 2, image 3, okay, and suppose put here up to image 23. It takes a lot of time. In this time, we are not follow this approach. In this time, we try to another approach. This approach is that I just take only one element. Suppose I take only for the one image, okay, and this image I just multiply with my scale factor. So for that, I use a function, return function, return this image and multiply with my scale factor 0.001. Okay, in this time, I just take only for the one image in my element, and this image I just multiply with my scale factor. But I have also rest of other images. Rest of 22 images is also available. So for that, what can I do? For that, I just use the another function. It's called the copy properties. So this is the function copy properties, and this function help you copy the properties after multiplication and then apply all of those images. So for that, I simply use here the element name image and put here system time start, and also put here the system time in. It means that system time start means that it's a system. This system I already give a time, start time and end time. You can see here I already put the start date and end date. Okay, and between this time I got total 23 images. And when I put here system time start, it means that this is the start time, and when I put here the system time in, it means that this is my in time, this time in time. So between this time I got total 23 images. So in this time, when I put here the system time start and system time end, it include all of those images, because this is my system time start. I already defined the time. This time I can got total 23 images. Okay, so now this is my function and this is my image collection. It totally separate. So this is the one code and this is the another code. There is no link, there is no connection. In this time I need to make the connection. So this is my function, this is my function, and this is my image collection. Basically this data set is stored at the 23 images. So now I want to make a connection. So for that, simply copy this variable and then paste here. For connecting, I just use a function, map function. Map function mainly it's connect my function with my image collection. So in this time, this is my function which I created, and this my image collection which is stored in the data set, total 23 images. I just use the map function for connecting to each other. So now in this time, this variable scale ndvi, this variable stored the reprojected the scale value. Okay, so if you want to check how many images I can got in here, we can get the same number of images. So just simply scale ndvi and use the size function. Then click to the run. So now you can see here it will be show the same number of images, 23 number of images, but in this time this scale and dvi is the reprojected. So I simply copy this and then further I reduce it. So just simply paste here, reduce, and then all of this will be same. Then click to the run. So in this time you can see here we can get the white color map. In this time we also need to change the mean and max value. Okay, mean and max value I need to change. So for that I simply put here that -1 to +1. Click to the run. So in this time we can get this type of map. And then suppose I click on the inspector tab and check the result. Suppose I click on here, you can see it show the value is the 0.2. Okay, click on here, I can get the value 0.7. So in this time this data set is reprojected. So that's how you can get the result belongs with our range of NDVI, -1 to +1. Okay, suppose I click on here, you can see I can get the 0.8. So it is the dense vegetation. High positive value indicating the dense vegetation, and low positive value identify about that sparse vegetation or no vegetation, or negative pixel value identify about that water body or other things. You can easily get the lot of information about that. Simply go to the link and you can see here it's very clearly all of those things will be discussed about that NDVI values range. You can see NDVI values range -1 to +1, and areas of the barren rock, sand, snow usually show very low NDVI values. For example, 0.1 or less than 0.1. It show about that rock, sand, snow. Okay, very low NDVI values. And sparse vegetation such as shrub, grassland, or single crop may result in the moderate NDVI. So 0.2, 0.5. High NDVI values approximately 0.6 to 0.9. It's the dense vegetation such as the temperate and tropical forest and the crops at their peak growth stage. Okay, so I also send you the link. After that you also try to read the full things, then you can easily get the better idea about the NDVI pixel value. So in this time here you can say I can get this type of map, and now it reprojected. Suppose I want to show this result for another country, suppose Pakistan. Click to the run. So now it show about the Pakistan NDVI map with their proper color combination, because it reprojected the scale value. And now it show this type of color. You can see it show this type of color. So in this time if you want you can also change the color stressing. Suppose I just stressing 80% or 98%. So for that simply click on here, and in this time it show about the custom. Okay, so just I stressed 98% this data. And now between this range, when I put this range on this map, then I can get the better visualization. Mainly stressing these things we are used to find out the value, which value show my result more better. Okay, so as I say stressing 98% and then apply. So in this time we can get this type of map. You can see this time this is the white color identify about the low vegetation, and this type of color identify about the high vegetation, or you can easily change it, this type of things. It's a default color visualization. It add from here. So now you can get this type of map. You can see, and from here we can easily identify the high vegetation, low vegetation. Suppose click on here, you can see I can get the high vegetation 0.5. Okay, suppose I click on here, you can see it's very show the very, you can see 0.009. Okay, so also you can see about that 0.3. Also you can see we can get the negative. Okay, so it's not a vegetation, it can be snow or water about that. So click on here, we can get the vegetation. You can see 0.5. Okay, so we can this time it show about the very better view about this map when I stress 98%. Okay, so basically this is the process, and further you can easily export this map. Suppose this map I can simply export, and further we can easily create this type of map. Suppose I show you some example which I already created. Okay, let me check. Suppose you can see this is the one kind of map for whole Bangladesh NDVI map. Okay, NDVI map year of 2020. So in this time, we are just download this TP image. Suppose this TP image we download from here, from the Google Earth Engine. This image we export, and then further we are using the ArcMap software or QGIS software to create this type of layout about for the add the legend or scale bar or all of those things can easily add in here. Also, you can see we can easily download this type of data, dim data or hill shade map, also slope, also aspect. We can easily download. Also, you can see this type of thing. You can see NDWI. Okay, so any kind of things we can easily download as a raster from the Google Earth Engine platform, and then further we can create this type of layout using ArcMap software or QGIS software. You can see all of those things we try to download from the raster, and further we create this type of map using ArcMap software. So how we can easily create this type of things, I also show you the later. You can see nitrogen dioxide density map, month of January 2022. So just we are download the data from nitrogen dioxide density map. After analysis, we can just download, and then this type of map we can easily create using ArcMap software for our research paper or presentation work. We can easily do it. Okay. Also, you can see the peak current map of White Bangladesh. So these type of things you can download from here. Also, you can see NDVI map of Saudi Arabia. So we are just downloading the data as a TIFF format, and further we are just using the ArcMap software to represent this type of map. Okay. Also, Bangladesh soil erosion. So in this time, we are just make the analysis in Google Earth Engine platform, and final layer we download as a TIFF format, and further we can easily create this type of layout using ArcMap software. As a linear regression trend analysis of for NDVI in Delhi. So this type of analysis we can easily do in Google Earth Engine platform, and final product we download as a TIFF format or raster format, and then further we can easily make the map using ArcMap software. And see the land surface temperature of the Ukraine. So these type of things we can easily do. Or land use land cover map, circus in Ukraine. You can see NDVI map. So any kind of things you can easily download as a TIFF format. So I also show you that how we can easily create these type of things for the next class. In this time, we can get the NDVI map, okay, from the Modis, okay, and you can suppose you have any specific boundary shape file, simply import the boundary shape file in here, and then you can easily get this prism. Suppose I simply work for the coastal shape, simply click on here. Okay, just I simply import, suppose you can say coastal shape, and further I just put this name, suppose coastal, and then further I simply copy the coastal, just clip with my coastal, clip with this variable coastal, and now I just also map.center object. Suppose I put here this coastal, I want to focus on the coastal boundary, so just use here the coastal, and then click to the run. So now it creates this NDVI map for coastal area year of 2023. Okay, we can get this type of result, but when I click on here, and then I just stressing suppose 98% for the better looking of this map visualization, and further I just simply apply it. So now we can get this type of map. You can see. So now further you can easily download this map as a TIFF format and make the map using ArcMap software for any boundary shape file. Okay, it represented the NDVI map year of 2023 for this study area. Click on here, I can get that for this specific coordinate. What's the value? 0.7. So basically the mangrove forest. So that's why you can see get the high NDVI value. You can see all time we can get that 0.6, 0.7. Okay, you can see 0.7. So it is a mangrove forest. So that's why it's a dense vegetation. We can get this high NDVI value. So I was click on here. I think it's a barren land. So we can get the, you can see this type 0.8 indicating the water body or rock. This type of things you can easily get from here. Simply click on here. You can see you can get 0.5. So in this time you can see it show about the world NDVI map because I put this layer name world NDVI map. So you can simply change the name in here. Suppose you can simply change the layer name, then it's also changed. Suppose I put this layer name, suppose coastal NDVI 2023. Click run. So now it show about this type. You can see coastal NDVI 2023. And when click on this map, then it will show about that coastal NDVI what's the value for the specific coordinate, what's the value you can get 0.6. So basically this is the process. So in this time I talk about how I can easily export this map. For exporting, export this map as a TIFF format. Okay. For before exporting, I also ready to discuss about the another things for the satellite image. How can you easily export the satellite image? Basically, all of those export is the same for the Landsat image, Sentinel image, this type of map. Okay, it's the same process. For exporting, I will show you the both of things at the same time. Then you can easily get the better idea. So in the meantime, anyone any question you can ask me. For any question regarding the full code, you can ask me. Or any confusion. Any question? Okay, so I think everything is good. Okay. So when you face any problem or any confusion, please just simply ask me. No problem. I also try to give the answer all time. Okay, so okay. So this is the process about the Modis NDVI dataset. Okay. In this time, I talk about that satellite image, how we can easily export the satellite image and then work with that. So let's go. So mainly filtering and visualizing the satellite image in Google Earth Engine platform. So basically, when you want to filter any satellite image, it can be Landsat or Sentinel. It depends on some factor. One factor is the region of interest. Suppose you want to need the satellite image for the Dhaka city, or you need the satellite image for any specific boundary. Okay. So first factor is your boundary or your study area. Second factor, image metadata. Suppose I need only for this image, which image will be not more than 1% cloud cover. So it's another factor for filtering cloud cover. Third, that you just need only for this image, which image is available for year of 2017. So it's the third factor. So when you filter Landsat or Sentinel, all time, it depends on three factors. First factor is region of interest or study area. Second factor, image metadata. Suppose I need only for this image, which image will be not more than 1% cloud cover. Third factor, specific time period. Suppose I need this image for year of 2017. I need this image for year of 2017, month of January. I need this image year of 2017 for summer season, rainy season, or any specific time period. We can easily filter. So filtering depends on three factors. You all time remember about that. So now let's take the practical example, how it will be work. So just I simply open a new code editor. And further, I just, okay, so just I simply go to this Landsat. Suppose I show you how can I filter the Landsat. So here you can say I can get the Landsat, this type of collection, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All of those image collection have the same filtering process. Okay, same. So in this time, suppose I show the Landsat 8, click on here. And further, I can get the surface reflectance, also get about the top of atmospheric. So basically, this surface reflectance is the two atmospherically corrected surface reflectance, and is the two calibrate top of atmospheric collection, TOA, mainly top of atmospheric reflectance, and it's the raw image. So in this time, I want to work, suppose both all of those image collection is the same for filtering. Okay, and mainly surface reflectance it used for land use, land cover, as well as also surface temperature. This type of things we are using the surface reflectance, and top atmospheric it's mainly used for different types of indices such as NDVI, NDWI, SABI, or any kinds of indices. When you want to use, then we are using the top of atmospheric. So in this time, suppose I want to work for that top atmospheric, click on here. So now I can get this type of information about the dataset availability 2013 to 2024 11th February. Okay, it's also updating, no problem. And dataset provider mainly USGS and Google. Artisan snippet, so basically it's a unique ID. Okay, it's a unique ID of this dataset, and you can see the description about this dataset. This dataset is all top of atmospheric reflectance and the calibration coefficient and extract from the image metadata. Okay, you can get all of this information from here, and we can get all of those bands. So mainly B1 is the coastal aerosol, then B2 blue, green, red, near infrared, short of infrared, short of infrared 2, panchromatic band. Mainly this band used for mainly increase the resolution and reduce the pixel area. You can see it's the 15 meter, and other band is the 30 meter. Okay, and also again the Cirrus B9 thermal infrared 1 reef sample 100 meter to 30 meter. So in this time I want to use this image collection. So first of all I need to import this image collection. For importing, just simply copy this collection, simply copy and paste in your code editor. Then give a variable name. Just I put a name, suppose and say, okay, you can put any name, no problem. So now this is my image collection, and this image collection I just store it in a variable Landsat. You can put any name. So now further I just filter. Okay, in this time I want to check how many images are available for the Landsat for the whole world between this time period, year of 2013 to 2024. How many images are available? So just simply use the print function and call this Landsat copy, and then use the size function. Okay, so basically size function determine how many images are available. So now click the run. Okay, computing for the whole world land surface LST Landsat image, how many images are available for the whole world. Okay, we can get the very large number image collection, but we are just simply filtering this image collection. Okay, so here you can see we can get the very large number image collection, more than 1 million image collection you can get from here. So in this time, this number image collection I got for the whole world between this time period, year of 2013 to 2024. This large number image collection I need to filter according to the region of interest, then image metadata, and also a specific time period. So first of all, in this time, this image collection is show for the whole world, but I need the image collection, suppose only for the specific study area. Suppose I need this image collection for the Dhaka city. Okay, you can say I already imported my boundary shape file. So how I can import the boundary shape file? Previous class I also tried to discuss about that. You also tried to watch, and then import. In this time, it's imported and show the result as a table. I put this name, suppose ROI. Okay, so in this time, my study area Dhaka city boundary is stored in the ROI. Okay, in this time this image collection show for the whole world, but I need this image collection only for the Dhaka city. Okay, so I just simply write the comment, suppose filter region. So for that I just take a variable, suppose filter region. You can put any name, and call my collection. I simply copy and then use a function filter bounds. So basically this function filter bounds, it's filtering the boundary. Okay, and here you can see what is the argument. Argument is the geometry. Okay, so in this time my geometry or boundary is the Dhaka city. It's already stored in a variable which is RY. I simply copy and paste. Okay, so now let's check how many images are available in Dhaka city. So simply print the filter region and then use a size function. Click to the run. So now it's computed how many images are available in the Dhaka city. We can got total 434 images. So these images are available in Dhaka city boundary. Okay, so basically this type of 434 images are available which is situated in the Dhaka city boundary. In this time, I need to more filter. Suppose I filter the image metadata. Okay, suppose filter metadata. Suppose cloud cover. I need only for this image less than. Suppose I need the image less than 1% cloud cover. Okay, so for that I just take a variable. Suppose filter metadata, and then from 434 images. Okay, from 434 images I need only for this image which image is less than 1% cloud cover. So simply copy and then paste. Then use the function filter metadata. So basically this filter metadata, this function help you to filter metadata. In this time you can see about that. First of all it show the name, then operator, then value. Name mainly image properties name. You can see here image properties. I want to choose suppose cloud cover. I simply copy the cloud cover and then further just put here cloud cover. Only operator. Operator, I choose the operator, suppose less than, suppose put the value, suppose 1. In this time, filter region, it stored total 434 images. From 434 images, I choose only for this image, which image is less than 1% cloud cover. And it is stored in a variable filter metadata. So just I want to check how many images are available. Simply print and call the filter metadata and use the function size function. Click to the run. So now we can get this result. How many images are available? We can get total 64 images. Okay, these 64 images is less than 1% cloud cover. But I need this image, suppose year of 2023. Okay, so basically this 64 images is available this time period 2013 to 2024, but I need this image for year of 2024, suppose month of January or February this time. So how I can filter it? So for that just take a variable, suppose filter date, and I call this filter metadata because this variable is stored at 64 images. From 64 images I choose only for those images which image is available in year of 2023. So for that just use the function filter date and put here the start date and end date. You can put any time period. So just I simply put here the time period year of 2000, suppose 24, suppose 1st January from year of 2024, suppose 0 to February, suppose 11. Okay, so in this time period how many images are available I need to check. Simply copy the filter date and then use a function size function. Click to the run. So now it computed how many images are available. In this time, you can see. In this time, it showed the totally 0 images. Okay. So between this time period, 2024 to 2024, suppose February, for my study area, I did not get any image, which is the less than 1% cloud cover. Suppose I just simply put at the 5%, then check what happened. Also not available. Suppose I put at that 10% and then check what happened. Not available. Suppose 90% and then check what happened. We can get the image, we can see. In this time, I get this image between this time period for my study area, which is less than 90% cloud cover. Very cloudy image I can got. Suppose let them check, suppose 50%, then check what happened. We can get 3 images available. Okay. Suppose I put here that 40%. I think the 1 image is available. I think it's the lowest cloud cover is the 40% between this time period. Suppose I put here that 30% and then check what happened. Okay, also 1 is available. So now I check about the suppose 25% and then check. I think we have to use at the less than 30%. Then between this time period, we can get this 1 tiles. Okay, 1 image we can got in here. Suppose I want to show this acquisition time about this image, when it will be acquisited. So just I simply print and filter date, click to the run. So now it show about that all of this information about this image. So I can get value 1 image. Here you can see the feature, only 1 image I can get, and I can get all of those properties. I can get this image cloud cover is the 27.97%. So this image cloud cover, and we can get all of those information about the band. So now I have to display these tiles. Okay, and you can see acquisition time. This acquisition time is that where it is, you can see the acquisition time from feature year of 2024, 5th January. Okay, 5th January we can get this 1 image. So now I just simply display this layer. So just use your map dot add layer, and I simply okay. So before that, what can I do? Before that, I just take a variable, suppose image, and then copy this ID. Okay, so I just click on the feature image collection and go to the feature, then 1 image, just copy this ID. Simply copy this ID. Okay, and then use a ee dot image and put here that. So now further, I just simply use our map dot add layer and call this image and click to the run. So now in this time, this tiles is loaded. Okay, so I want to focus it. So for that, just use our map dot center object. Suppose object is the ROI. Suppose 10. Click to the run. So now it focus on my center of the shapefile. In this time, you can say I can get the very cloudy image. Okay, I can get only for the 1 tiles between this time. So further, it look like that, and it's the lowest cloud cover image between this time period you can get. So in this time, I simply click on here. Suppose I set the band combination such as red, suppose green, and put at the blue, and cast of 98%. Apply. So now you can get this type of image, as you can see, but this image is very cloudy. Okay, you can see there's a lot of cloud. Suppose I just use we take the long time period. Suppose I put the time period year of 2023. Suppose December to 2023, January to December. Suppose put here that December 12, suppose 31. Okay, all of those images including in year of 2023. So now let's check how many images I got in here. So now click to the run. In this time, I get total, and I also choose here the less than 1%. Suppose 1%. Click to the run. So now it display this result. How many images you can see? I can get only for the 6 images. Okay, 6 images. This 6 image is the less than 1% cloud cover. This 6 image is available in my Dhaka city. Okay, and this 6 image is available between this time period for 1 year. For the 1 year, I can get for my study area total 6 images. And you can see here also get their image acquisition time for the total 6 images. You can see the first image year of 2023, 18 January, 7th March, 8 April, 3rd February, 8 April. We can get the 2nd November. So we can get all of those images. In this time, suppose I want to display this layer. So click on here. Simply copy this ID about this style. Simply copy. And then further just paste here. So now I just simply uncheck the comment and also add a layer and focus the center. So now click to the run. In this time, it display the image year of 2023, 7th March. You can see it display the tiles about that. We can get this type of tiles. And these tiles, cloud cover is the less than 1. So further, I just simply click on here. And suppose I want to add the band combination, such as red, then green, and then suppose blue. And further custom stretch 98% for better looking. And then apply it. So now we can get this type of image collection. You can see. We can get this type of image collection. But these tiles have a problem. This problem is that it's not cover my study area. Suppose I just simply add the layer of my boundary shape file. Then you can easily get the idea. Suppose we have not add layer. I want to add the layer for study area, RY. Click to the run. So in this time, it also added the boundary of my shape file. This is my boundary. I need this image which is fully cover my study area. But in this time, you can see it loaded. Yeah. This is my study area and this is my image. Okay, you can see this side is not completed. Okay, this side is not completed. So basically this time, these tiles is not completed. So for that, in this time, I just simply use the another tile. Suppose click on the feature and check the second image. Here you can see the second image. Copy this ID, and further paste here. I simply change it. Okay, the same. Suppose I try to check about the third image. So just simply copy this ID, paste here, and then check about this tiles. What happened? So now click to the run. In this time, you can see this is my study area, and it also it's also not completed. This tiles is also not completed. So try to check the another tiles. Suppose this tile I want to check. Simply copy and also copy these things. So now click to the run. So now you can see this tiles is fully fill up my study area. So this is my study area and this is the tiles. So this tiles is fully fill up. So that's why I can easily use these tiles for the different types of analysis for my specific boundary. So you can see here, this image acquisition is the year of 2023, 3rd February. Okay. So just I simply click on here and then further add the different types of band combinations. Suppose I add here that band 4, red, then put here the green, and then put here that blue. Custom stretch, suppose 98% for better looking, and then apply. You can see it will successfully cover my study area. So for that, I just simply use a function, clip function, clip with my study area, such as RY. Okay, and you can see import option. So in this time, I just simply click on the import. You can see it added the new line of code. I simply copy the variable and paste the variable after object name, because always after the object name we always put the visualization parameter. Then put the layer name. Suppose I put the layer name is a suppose true color. Suppose true color. Okay, click to run. So in this time we can get this satellite image only for my study area. It's just click. You can say you can get this type of image. Suppose I want to add the another layer for the false color. So how I can do that? Simply click on here again, and then set the band combination such as near infrared. Then put here that red and blue. Then suppose state 98%, and then apply. So now we can get that false color composite. In this time we can get the visualization as a red color, water show as a black color or dark color. So I simply import that. Import. You can see it will be imported as a new variable. So in this time I just simply copy. I just add another layer about this color. I simply copy this visualization parameter from here and then paste and put the layer name suppose false color. Now click there. In this time you can see it added the two layer. One layer is for true color composite, another layer is for false color composite. It added the two layer. Suppose you want to add another layer, suppose click on here. I just simply add the band combination, different types of band combination. Suppose I set the band combination for short wave infrared one band B6, then put here that near infrared band 5, and then put here the suppose green band, and then custom state 98%, and then apply. So now we can get the another band combination. You can see it show this type of things. Basically this band combination we are used for that monitor the agricultural land. So just I simply import. Okay, it will be imported. So just I simply add the another layer. Just simply copy and then paste. I simply copy this variable name and paste after the object name, and put the layer name suppose I put this layer name suppose agriculture. Click the run. So in this time we can see this type of things. It added the three layer. You can see agriculture, false color, true color. So we are at the different types of band combination. And this image acquisition time is the year of 2023, mainly 3rd of February. Okay, this time. So it's called about the single image. Okay, so it's a single image. In this time, I talk about the composite image. So how we can easily create the different types of composite. Suppose I just use all of those images and make the composite. I just create the mosaic or median, this type of composite, how we can easily create in Google Earth Engine platform. So it's the single date image. So single date image. So for that, simply copy this ID about this image, then we can get the single date image or single time period image. In this time, I talk about the image composite, how we can easily create the median composite, mosaic composite, this type of composite, how we can easily create. So in this time, I again explain this code one by one. So first of all, I just simply import the image collection land set. Here I can get total image collection. Mainly, you can see large number of image collection I get. Okay. So this image collection, I just filter according to my region of interest. So mainly higher. Okay. Where you need this image? I need this image mainly RY. What is the RY? RY is the Dhaka city boundary. Then also you can see I need only for this image which image will be not less than 1% cloud cover. So I filtered this image metadata less than 1%. So it's mainly how. And then I filtered the specific time period, mainly when. Okay. So basically where, how, and when. These three things we are used for filtering. Okay. So mainly where is identify about your specific boundary, how it's identify about the your filter metadata, and when for a specific time period. Then we filter our image collection. After that, we can get the only for the 6 images, and this 6 image we can get there all of this information, such as all of those acquisition time period. From here, I want to show only for this single time period image, this image. Simply copy this ID and use the function e.image and paste here. Then click with my study area. And before that, we have to check this tiles is fully fill up our study area or not. We have to check it and then work with that. And then we are using the different types of band combination. So now any question you can ask me about that. Yes, please.
Okay, hi. I missed something, especially in line 12 and line 16. At the end of the filter date or filter something there, I saw you put in the brackets before changing it to cloud cover and all that. I saw that there was a property, there was name and value. So where did you get that? I didn't see that part. In line 12, after filter metadata, in brackets, there was property, there was name and value. So where did those come from before you insert the cloud cover and lesson and the one value for the NDVI? Thank you.
Filter metadata, it's a cloud cover, it's a properties name, image properties. So we can easily get these properties from here. You can see image properties. I want to use the cloud cover and then put the less than 1%, less than 1%. So how I can get it? Suppose any function, suppose I put a function filter metadata, okay, and then press Control and space on your keyboard at the same time. Then it show all of those argument. Okay, so just simply press on your keyboard Control and space. So mainly it's the CTRL button plus space. Okay, in your keyboard. Then it will be show all of those argument, name, operator, value. So in this time, name is the image properties name, cloud cover. Operator, I want to choose the less than, and value 1. So in this time, it filter metadata cloud cover less than 1% or 1. Okay, so just simply write your function and then press Control and space. Then it show all of those argument. Then we are just simply fill up this argument. Then it will be work. Okay, so any question?
All right, understood.
Okay, thank you. Okay.
Thank you.
Okay, so in this time, we are just filtering these things, and here you can see when I filter the where, I just use a new function. When I filter how, I use a new function. When I put the when, I use a new function, and also take the new variable name. We can see filter date, filter metadata, filter region. So individual function, I took individual variable name. But in JavaScript programming, we can just only use the one variable, and under this variable I put all of those function one by one. So then it reduces our line of code. So first I show you that how it will work. So let's go. Suppose I simply comment all of those lines together. So just simply comment all of those things. Just select and press Ctrl and /. It will be commenting. In this time it not work. So in this time, I just work from here. Suppose I just simply import my image collection. So now I want to filter without take any new variable. I just all of those things just only use the one variable and set. So in this time, how I can do that? So for that, I just use a dot notation and put the suppose filter bounds function. Okay, mainly it's your boundary where you need this image. I need this image for Dhaka city, so it's stored the ROI. So just is where the ROI. Okay, then put here the filter metadata. Okay, so in this time we put here the name, operator and value. So name mainly cloud cover, we can get it from the image properties. Operator mainly it's a less than. Suppose I need the less than 1%, so put here the less than and set the value for 1. Okay, and then put the another function filter metadata. and put this time for a specific time, filter date function. It will filter date and put this time period, start and end date. Suppose I put this time year of 2023, suppose 1st January, from year of 2023, December 31. In this time, I filter my image collection according to the where I need this image, then how I need this image, less than 1%, and then when I need this image. Okay, I simply use the filter bounds, filter metadata, and filter date, and all of those things is stored in one variable. So now when I print that, suppose I simply print this variable land set, it show me the final result. You can see here I can get this, how many images I get, only for 6 images I can get. Okay, for the Dhaka city. Okay, and you can see all of those it is a single date image. So it's a single date image. It's a single date image. So when you want to work with a single date image, just simply use the same process. Just simply copy this ID and work with that, and then clip with your study area. So then it will work. So in this time, I want to create the composite. Suppose here I can get total 6 images. Okay, these 6 images I want to use and then make the median composite. Median composite, mainly it take the middle pixel value of your image and create this composite. Suppose I just use a function, median function, and then use it. Suppose just write here median dot median. So in this time, this function take the middle pixel value of total 6 images and create this composite. So now in this time, I just show you the layer. Suppose I just simply add a layer, map dot add layer about this land set, and click to the run. In this time, it create the all of those middle pixel value from total 6 images and create this type of composite. You can see. You can see in this time all of those images connect to each other, all of the styles, and create this composite. So basically it's very important when you want to work for the big region. Suppose you want to make the composite for the whole country boundary of Bangladesh, then single tiles is not possible. So for that we have to composite, or we need to mosaic all of those all of those styles we need to composite and then create this image. So now I just simply clip with my study area after median. Suppose clip with my study area, which is ROI, click to the run. So in this time it just clip with my study area, you can see. And this image is created from total 6 images middle pixel value using median composite. So I have to set the band, suppose band combination from here. Suppose I set here the before red, then green, and RGB color, mainly 2 color I think, and then stretch 98% spacing, and then further apply. So now I can get this median composite of land set images between this time period. All of those images, mainly total 6 images, are create the median composite. Okay, so here I guess I can get this type of image in here. So click on here, then you can see it show about the all of those pixel value about that. We can easily get B1, B2, B3, all of those one we can easily get from here about the specific coordinate. So in this time, this is our image. Okay, it's the median image. Okay, so in this time you can easily use this image and then work for the different types of analysis, such as make the NDVI or NDWI, make the land use land cover map or anything. So basically this is the 2 way. One way is that you can easily get the single date image, or if you want you can easily get the median composite image. Also we can easily take the mosaic image. So further also already discussed about the mosaic. So in this time it create the median composite. Okay, I just simply click on the import, you can see, then simply copy this variable and then paste after the object name. Just I put this layer name, suppose now click the run. In this time we can get the layer about that. Okay, so now I want to talk about that how we can easily export this type of image. Suppose this type of image, how we can easily export, as well as this type of map. Suppose after creating the NDVI map or from the Modis, how we can easily export this type of things. And then this type of things we can easily use in the ArcMap or QGIS software for creating the different types of map. So in this time, suppose these are satellite images. So basically in this time you can see when I basically this is our code for getting the any satellite image for any region. Okay, you can easily change the ROI, and then we can easily change the time period. We can easily use the same code for any region. And first time I try to discuss all of those things for your understanding, mainly how it will be work, filtering one by one. I try to, but next time when you want to write the code, you just follow only for this code. Okay, then it will be very work well. Okay. So in this time, I try to discuss about that how we can easily export this type of image. Mainly for exporting, we are just use the function. This function called export image to drive. Okay, so it's the function. I simply put all of those argument. You can see. So it show about all of those argument, image, description, folder, file name prefix, dimension, region, next pixel. So first of all, I try to open this function in our Google, in our Docs tab, and then try to disable all of this argument. Suppose simply paste. And see here, this is the function. So basically, this the function, mainly we use it function to export an image, mainly raster format image, as a TIFF format in our Google Drive. And here you can see the argument. First argument is the image. The image to export. Mainly which image you want to export. Simply write this variable name. In this time, I want to export this image. And what is the variable about this image? Mainly this image is stored in the land set. Okay, you can see when I add map.add layer and call this variable, then it show the layer. Okay, so now this image is stored in the land set. So this is my image value. Okay, then also in the description can be anything. We can put anything. Mainly you cannot use the letter, number, or no space. Okay, you did not use any space in here, then it will not work. So you can put the name without space. Folder, you can just put the folder, any name you can put. Okay, and this folder automatically create in your Google Drive. Okay, and then file name prefix. So mainly in this time it's optional, it's not need. So mainly when you want to it's prefix, mainly it's a prefix, may contain the letter, number, other things, or dimension. Also in the region, it's very important. Basically region is that a specific boundary or polygon. Okay, it's a specific boundary or polygon. In the scale is the resolution in meters per scale. Okay, mainly it's your is satellite image resolution. Okay, so in this time I fill up all of those things one by one. So just make a dictionary, curly bracket start, curly bracket end,